Hello, my dear young and energetic physiognomy. A very warm welcome to Diksha Vedantu YouTube channel. I am your master teacher Neha ma'am. In today's session, we are going to discuss the important questions from the chapter Motion. Okay, so just give me some time. Let me check that. Is live started properly? Can you see me and hear me properly? If you're watching the video, let me know your presence in the chat. Yes, I hope it's fine. So, hi, Nandini. Okay, great, guys, good. So, the live has started, and I hope audio is also good. Yes, audio is also proper. So, there's no problem. We are good to go. We are good to start, right? So, already I have completed the motion chapter. Okay, it may be motion in a straight line or motion in a plane. We have discussed the 11th standard motion chapter, connecting it with the 9th standard chapter, right? So, from the 9th till your 11th concepts that exist in the chapter motions, and also we have solved many questions in that sessions too, right? So, additionally, taking some of the NCRT good questions we can discuss today so that we can make more clear what we are studying here, right? So, am I clear? Shall we start the class then? Are you guys ready? Okay. Oh, yes. So then, okay, guys, let me start then with the session. Right. So I hope you can see the slides properly, right? Everything is visible, clear. I hope that. So with that note, let's start today's session, the important questions that has to be discussed regarding this chapter. Okay, before starting the session, let me give a quick update regarding hello Drishti. Hi. So let me give you a quick update regarding Vedantu Learning Centers. So Vedantu Learning Centers are out now. They are across India. You can find it by your near location, right? From Jammu Kashmir, Punjab, Bihar to Rajasthan, Maharashtra, Karnataka, Tamil Nadu, Telangana, Andhra Pradesh, Chhattisgarh, Odisha, Bihar. Okay, everywhere across India, the Vedantu learning centers are spread. So, if you want to avail any courses, if you want to have that classroom interactions, then you can check out. The link is in the description, right? Go to the link. You can scroll, you can know about the things, how the things go on there. You maybe you may be searching for a JEE course, NEET course, foundation course, whatever it be. Just go with the link, or else you can call to the number that is given on your screen. So just 1800 120 456456. On this number you can call and get the details regarding Vedantu Learning Center. So is that clear? So limited seats are available. So just you can, if you're interested in that, you can check it out. Okay then. And also you will be getting quickly update in a live by the teachers regarding the KCT test series. Those students who are attending for the KCT test series, there is a surprise for you guys. So just giving you an update that if you want to avail that test series, so you can just find the link in the description. So a very good offer, discount price you can get from here, right? So don't miss out that. If you are interested, if you are attending the KCET examination, so one of the best, what I can say, the test series you can attend here, right? So moving towards the question number one. So that is already on our screen, right? So, shall we start then with the questions? Are you guys ready? Yes, are you guys ready? Okay, just let me start with that. Yeah, great, guys. Good. So let us start with the session. So let me read out the first question that is given on your screen. In which of the following examples motion can the body be considered approximately a point object? Okay, so they are asking in which of these condition we can consider that object or that body as to be as a point sized object, right? So this is the question. Let me just choose the pen here. Right. So what are the options? So is yeah, we have to state which of them can be considered as a point-sized object. Okay. A railway, okay, carriage moving without jerks between two stations. A monkey sitting on the top of a man cycling smoothly on a circular track. A spinning cricket ball that turns sharply on hitting the ground. A trembling beaker that has spilled off the edge of the table. Okay. So, yes, Hema, you're telling B. B can be considered as a point object. A monkey sitting on the top of a man cycling smoothly on circular track. So, what's is the things? So, let us know that. So, the railway carriage moving without jerks between two stations. So, the distance between the two stations is considered to be large. So first you should know if I should call anything as a point sized object, what should be the condition? If there is something, one big table on that one small piece of uh, what I can say, any coin, any object is there. So I can call this as point size, right? If I'm keeping this point size in a small area, I cannot call this right. So that is what they are explaining here. So see here, therefore train can also be considered as a point sized. Understanding what I'm saying? So the first question before telling what is the point sized object, you should know what is that means. That means there is something very big on which there is some object which is very small comparison to this. Right? So we are comparing. By that analogy, you should answer this question. So, if I consider a railway carriage moving between two stations, the meaning of point sized object. Yes, I'm explaining that. Yes, I'm explaining that. Because before answering to the question, we should know what is the point sized object, right? So, no worries. You don't know that? No worries about that. We can understand. So as I said, if we are considering something very big and upon that very small thing, so then we can call it as a point sized object. Okay, now see, two stations. Where will be the two stations? In two different places, right? The journey, the length of the railway station are so long from one place to other place. So on that, if I consider one carriage, it's very small in comparison to the distance between two stations. Am I clear with my words? Understanding what I'm telling. So, what is the thing going on with monkey? Monkey may be considered as point-sized object because value of distance covered on a circular path is much greater. So, wherever the path or the things are greater and the object is small, we are calling it as point-sized object. Clear? So the monkey may be considered if the person is traveling a greater circle, a greater distance, a greater path. If he is covering, then we can call, yes, monkey can be considered as a point sized object. Is it clear now? Good. Okay. Okay, Hema, good. That's good. So next was a spinning cricket ball that turns sharply on hitting the ground. Okay, as the turning ball is not smooth. So here we are discussing about another condition, the smoothness and the hardness. Right? As the turning ball is not smooth, thus the distance covered by the ball is not large. Okay. So see here, the interesting thing that is appearing. If the ball is smooth, then it will travel larger distance. It is not smooth, okay? So it is traveling shorter distance. Yes, hi, Prashant, hi. Okay, as the turning ball is not smooth, thus the distance covered by the ball is not large in the reasonable time, right? So therefore, ball cannot be considered as a point object. So again, by seeing this, we can consider them, right? So I'll be telling it finally. Let's see fourth example also. A tumbling beaker that has spilled off the edge of the table. So what's going on here? Again, the tumbling beaker spilled off the edge of the table cannot be considered as point-sized object because distance covered is not much larger. It is just spilled off. It's not flowing and it's not very big. So finally, by seeing all this, I can conclude one thing. If I want to consider anything as a point-sized object, right? If I want to consider anything as a point size, so I can know that the distance what it should travel or it is traveling, distance covered, I can say, distance covered should be very big, should be very big in comparison with the object size. Okay, in comparison with object size, then I can say that in comparison with object size. Then I can say that as point sized object. Clear with this? Did you got to know now what is point sized object? Right? Shall we move to the next question then? Clear? I hope that's clear. So these are the answers. So railway, carriage and the distance between two stations. Yes, great. So that can be considered as a point-sized object. Monkey can be considered as a point-sized object as it is covering a big circular track. But the ball, when it is getting hit, it is not covering larger distance. So ball cannot be considered as a point-sized object. And also the water or the water of something that is spilling out of, right? So it is also not traveling a larger distance. So we cannot consider that to be a point-sized object. Okay, right. So then let's move to the next question now. Okay, moving forward with the next question. And I have already done this theory session. Let me inform you guys that. So we are already completed with the theory part, the explanation of motion chapter. Okay. So the second question is on your screen. So let me read it out. The position time x minus 1 graph, okay, for two children A and B returning from their school O to their home P and Q respectively are shown in a figure. So there are two children named A and B who are returning from a same school, but their homes are P and Q. Okay, it is shown in the figure. Choose the correct entries in the brackets below. Okay, we have to choose among them which is right. Okay. So A by B lives closer to the school than B by A. Okay. So we should first find who is near to the school. So this point O is the school, right? Okay. And the time. So I can consider A is leaving the school quickly, but B is leaving the school little delayed, right? He is not leaving the school as the time of A. Okay. So next, where is P? P is near to the O, right? So I can say P means who is it? Who is it? It is A. I can say A is staying near to the school than Q. Fine. So A is staying near to the school than Q. And but are they reaching to their school? I mean, are they reaching to their home? So this is what B is trying to reach, and this is what A is trying to reach. So by seeing this, I can say A is walking slowly, right? The home of A, so listen to my words carefully. The home of A, that is P, is near to the school, but he is walking so slowly that B is reaching before A. Clear? So what is given? B by A starts. Oh, I'm not getting why by they have given. A lives. Okay, let's understand what we know. A lives closer to the school than B. Yes, what is the doubt, Sanjana? What's the doubt? Yes. Yeah, what is the doubt? I asked you, right? The question. You have the doubt in the question? So, see, I think there's, if this is a doubt, let me clear. This is not x minus 1. This is xt graph. So, what is the doubt in the question? Yeah. What is the doubt in the question? The position time graph of two children A and B returning to their home from school is given, right? Was it the same? This doubt you were having? XT graph. Now it's clear. Yes, Sanjana, is your doubt clear now? Cleared. Good. Very good. Okay. Now I will not consider this A by B by A. Let's leave it. So A lives closer to the school than B. Yes, A lives closer to the school than B. A starts from the school earlier than B. Yes, again, as I said, B is taking more time. Okay, B is taking more time, but A is leaving the school earlier. Yes, A starts from the school earlier than B. This is also true. A walks faster than B. No, A is walking slower than B. Because of that, if his home is present near also, he's not reaching it quickly, right? But B is reaching to the home in a less amount of time. You can see in just small time interval, B is reaching in just this time. But see the time taken by A to reach the home. He's not still reaching. It takes more time for A to reach his home, right? So, yeah, this is false. Okay. A and B reach home at a same or different time. A and B reach the home at different times. They reach different time. If same time, I could have seen a line going like this. Okay, if it is like this, in the same time both are reaching, I could have called, right? But it's not true. A is not reaching quickly, and they are not reaching at a same time. Clear? Are the solutions clear? A overtakes B on the road once or twice. So I can see here overtaking only once. Clear? So B is overtaking. A overtakes B. A is not overtaking. B is overtaking A once. Right? So A leaves closer to than B because B has covered higher distance. Yes, B covers larger distance because he is living far. A starts earlier from school because A is starting the school, leaving from his school at t is equal to 0, but B takes some time. Okay. As the slope of B graph is greater than A, thus B walks faster. You can consider the slope also to find out who is walking faster. Okay, this is the slope of B and this is the slope of A. As slope of B is more, you can say he's moving faster, or by just seeing that in a short amount of time he's covering a large distance, so that is also speed. Covering large distance in short amount of time means he has more speed. A and B reach home at the same time. Okay, so let me check with that. A and B, I couldn't see that because the graph A, okay, so it's covering the distance, it's covering this distance. Okay, it is reaching the P. Okay, if I say there is the X distance between the home of A and the school, so then it is covering that X distance. Sorry, so I didn't saw here. It is covering their X distance, right? At the same time, it's covering X distance, and the other one maybe some more than X, right? So both are reaching their home at the same time. Okay. At the point of intersection, B overtakes A on the road once. Yes, B overtakes A once. That we can see here. As I said, B is overtaking A once. Clear with this? Okay, great. Moving forward with the third question now. I hope the two questions are clear. So one was based on the point science of object and the other one was a graphical question, I can say. Right? Simple concept as speed, distance, time, but in a graphical format, they have asked comparison between two different things, two different people. Yes, what is the doubt now? What's the doubt? Okay, so let me move forward. Whatever the doubt you have, you can ask that. Oh, a woman starts from her home at 9 a.m., walks with a speed of 5 km per hour. Okay. So she's leaving her home at 9 a.m. and she's walking with a speed of 5 km per hour on a straight road up to her office, which is 2.5 km away. Stays at the office till 5 p.m. Okay, till 5 p.m. she works in the office and then returns to her home by an auto with the speed of 2.5 km per hour. Choose the suitable case and plot the graph. Okay, what is the suitable case? Okay, we have to do it. See, let's understand now what's going on. So, what's going on here? At sharp 9 a.m., she starts walking, right? Walking with the speed of 5 kilometer per hour. If I consider, so what xt graph, okay, distance time graph they are asking. So 5 kilometer per hour, I can consider slow speed, right? So let me once check this. She walks with a speed of 5 kilometer per hour on a straight road to her office, which is 2.5 kilometer away. Stays in the office up to 5 p.m. and returns to home by the auto with the speed of 2.5 kilometer per hour. Suitable scale? Okay. Okay, let's see then. So 9 to 5 o'clock, she's not moving, right? She's not walking, she's not moving. So what will be the distance time graph? It will be a constant as she's not moving. But first she left from her home to office, and then from office to home. So that kind of graph you can see here, right? You can see what is going on here. In 9 o'clock she is leaving. Okay, so this is considered to be 9. Okay, 9 o'clock she is leaving her home. She travels 2.5 kilometers, which is given here. Okay, and when she is reaching her home at 9, sorry, her office at 9:30, she is reaching her office. Okay, so understanding what's going on here, let's solve it. The distance, let me call it as S is equals to 2.5 kilometers, and the speed which she is walking is 5 kilometer per hour. And let us calculate the time what she takes to reach there. So we know that, so this is speed. We know that speed is equals to distance by time. Just rearranging the equation, we get time is equals to speed, sorry, distance by speed. So time is equals to distance is 2.5 and speed is 5. So 2.5 ones are 2.5 twos are. So what is the time? Time is half, nothing but half an hour. That is 30 minutes. So let me write here hour, and she takes 30 minutes to reach her office. Clear with this? Understanding how she is reaching at 9:30, because it takes 30 minutes to complete her journey. Fine. From when she reaches at 9:30. 9:30 to 5 p.m. she is working. Okay, that's good. So till this time, it is just a constant line because there is no velocity, right? V is equal to 0 at this time. She is not moving anywhere. She is working in her office. So next, what is happening? We have to calculate another time here. Okay, one more time thing we have to calculate. Let me write with the cello. So don't get confused. So again, she have to cover the same distance, which is 2.5 kilometers. But now the speed is 2.5 kilometer per hour. Okay. But now she's taking the speed of 2.5 kilometers per hour. And according to this, if I calculate time, it turns out to be 1 hour. That's not true. If I consider 25, let me check it. If I consider speed to be 25 kilometer per hour, then what will be the answer? Uh, I guess is this, let me check it out. Okay, so see here, distance covered is, as I said, while walking 2.5 kilometer, right? Okay, there's no problem with this. And she is walking with 5 kilometer per hour, and we got the time to be half an hour. This first part is done. If O is the retarded as the origin for both the time and distance, then at time t is equals to 9 a.m. she is leaving, and 9:30 she reaches her office. It is also done. We saw this. OA is the XT graph of motion when the woman walks from her home to office. Her stay in the office is from 9:30 to 5 p.m. Okay, this is also good. So 9:30 to 5 p.m. She's not moving anywhere. So it is a constant graph, which is a straight line. Okay. Now time taken by her to return the home by auto is 2.5 by 5 hours. So now, so 5 hours they are taking here. Let me, that is 1 by 10 is equals to I can find some. I think there is some error here because 2.5 by 5, 2 ones are, this is 2.5 ones are, 2s are. It again turns out to be 1 by 2. What they are telling it is 1 by, okay. So let me check. I think there is some error here. 2.5 by 25, if I consider, it will be 2.5 by 2.5 into 10. Right. So see students, this is not the 2.5. Okay. Auto will not move slower than what the woman walks, right? So the woman is walking with the speed 5 km per hour. Then absolutely auto will move with the more speed. Right. And what is the more speed? It is 25 km per hour, not 2.5 km per hour. Okay. That is what I think was the mistake here. So if I consider the speed of the auto to be 25, so let me solve it here. 25 km per hour, then we can get the right answer. Okay, please observe to this question. If you are getting these kind of questions, sometimes observe there may be error in the questions also, as we can find here. So again, time is equals to velocity, sorry, distance. Distance by velocity. Distance is 2.5 and the velocity is 25. Okay, is it repeating? Sorry, one second. Yeah. So now what I can do, I will write this 2.5 as it is and I can convert 25 into 2.5 into 10, right? Because again, if I multiply this 2.5 into 10, it turns out to be 25. Okay, so I'm getting the desired result, right? So now 2.5, 2.5, just cancel them. And what it turns out to be 0.1. 1 by 10 is 0.1. So actually, she should reach at 5.01. Oh, yeah, that is 0.1 hour. So what is 0.1 hour? Again, we have to calculate that. Okay, interesting question. So 1 hour is equals to 60 minutes. 0.1 hour is equals to, I should remove 10 power minus 1 from this. So that is 6 minutes. Okay, very interesting question. But there was a little bit of error, which is the speed of the auto is 25 km per hour, not 2.5 km per hour. But a quick, good question. Understood? So, did you got to know how that 1 hour I converted it into 0.1 hour? So this we already know, right? So multiply this equation with what I can say, or divide the equation with 10 or multiply the equation with 10 power minus 1. You'll get the result what I have written. So that how she reaches her home at 5 hours 6 minutes, right? Yes, 5 hours 6 minutes. Clear now? Good questions. There are good questions in today's session, right? So keep and if you have any doubt, yes, please go ahead, ask your doubts. Clear? Great. Okay, good. Then let's move forward. Yeah, shall we move forward now? Any doubts from this question? Yeah, if you're finding any doubt in the question, if you're not getting the answer, let me know it. Good question. Fine. Shall we move forward now to the next one? Again, I'm repeating, if there is any doubt, you can ask that. Okay, let's move to the next question. Question number 4. A drunkard walking in a narrow lane takes 5 steps forward and 3 steps backward, followed by 5 steps forward and 3 steps backward, and so on. Okay. Each step is 1 meter long and requires 1 second. Plot the xt graph of his motion. Determine graphically or otherwise how long the drunkard takes to fall into a pit which is 13 meter away from the start. Okay, when he will go and fall in that pit, we should calculate that time. Uh, so he is taking 5 steps ahead. So if I want to draw a xt graph, we can do that. So let me try here. And let me consider 1, 2, 3, 4, 5, 6, 7. I think more steps are required. Okay, once let me erase this and draw it once again. Let me consider 13 steps where he will fall in the pit. So 5 steps ahead, 3 steps backward. Okay, so let me consider here 3, here 5, and then plus 3, 8. Okay, it will be a non-linear graph. So taking it in this way will not be proper. But what I can explain you here is just observe. If I draw the graph like this, he is moving 5 steps in 5 minutes, and next in upcoming the 3 seconds he is moving this downward, and then he moves again 5 steps in 5 seconds, and again in 3 minutes. Okay, will the graph will be looking like this? Can you relate with this what I'm drawing here? He is moving 5 steps forward, 3 steps backward. 5 steps forward in 5 seconds and 3 steps backward in the 3 seconds. Again, next 5 seconds, 5 steps forward. So the graph is moving upward direction, which is representing he is moving in forward direction. And here 3 is moving downward direction, representing he is moving in backward direction. Right. Finally, what I can consider, sometimes he's moving forward, backward. His motion is going on like this. But you can see that here, since the man is steadily moving, okay, uh, after 13 meter, there is a pit. So we should calculate in what time he'll go and fall in that. In 5 seconds, he moves, okay, forward, and in next 3 seconds, come back. Thus, in 8 seconds, what is the total distance covered by him? So interesting. So instead of taking him forward, backward at every time, we can consider the 5 meter he is moving forward in 5 seconds, and then in next 3 seconds he is moving 3 meters backward. Let me consider it to be minus 3 as it is in opposite direction. So totally what I can consider, in 8 seconds he is 2 meters forward, right? He came 2 meters forward than his initial position, right? I can say that, right? So in every 8 seconds he is moving 2 meter ahead. So what I can consider here, if I go on considering the multiple of 8, in the 16 seconds, he will be 4 meters away, right? In the next seconds, right? So he'll be again moving forward. So how long it takes for him? Just looking at here, how long it takes. As the point is earlier, this man covers 2 meter ahead in 8 seconds. So he will cover 8 meters in 32 seconds. But at the but at the end in 5 seconds, he would cover the rest 5 meters. So here it is, how much he covered? 8 meter plus 5. So that gives me 13 meter, right? So that's the distance of the pit. So when he is going to fall, so it takes 32 seconds plus 5 seconds, and then he will be falling in that pit. Am I clear? Got it? So what they have drawn here, the distance, it is he is reaching the distance is maximum 30, and then he is going to fall. Clear with this? In the 8th second, right? In the 8th second, he is going to move just 2 meters ahead. Clear what I'm discussing? So yes, again a good question. So you should know to understand this, these kind of concepts. What happens in the ninth and 10th, we'll be just directly going on some applications level. We will be seeing because of your case study, that is competency questions, right? But here all questions are like competency. That means you have to use your mind. Not only just the concept, you must use your brain. That in a 5 second the person is moving forward, in the next coming 3 seconds he is moving backward, so totally in the amount of 8 seconds he's just moving 2 meters ahead. So in the, yeah, we calculated it, right? So if I get it 16 seconds, what will be the result? And if he travels 32 seconds, right, then he covers 8 meters. Understanding? So you should consider these kind of questions. Good question again. I hope that's clear. Right? Any doubt? Is there any questions? Clear, right? Okay. So what's the next question? A jet airplane traveling at the speed of 500 kilometer per hour ejects its products of combustion at the speed of, so the speed of ejection is 1500 kilometer per hour relative to the jet. Okay, it's not the speed of the ejection, but it is relative velocity. It's not the absolute velocity. What is the speed of the later with respect to the observer to the ground? So the concept of relative velocity is being used here, right? uh, Let me state you. So see here, the velocity of jet airplane with respect to observer is 500 kilometer per hour. So the jet is moving forward with a speed of 500 kilometer per second with respect to the observer who is watching it. If Vj and Vo represents the velocities of jet and observer respectively. So what is the original velocity of jet? It is Vj. Clear? Clear with this? What is the original velocity of the jet? It is Vj. And what is the observer seeing it as? Vo. So that is 500 kilometer per second. Nothing but relative velocity. Got it? Yeah, got this. So let me write it here. Let me give you here the thing. relative velocity of the jet with respect to observer is velocity of jet minus velocity of observer, that is 500 kilometer per hour is what given, right? Okay. Similarly, if Vc represents the velocity of the combustion product with respect to jet, so then what is the velocity of the combustion or velocity of ejection? Velocity of combustion, that is Vc with respect to the jet, so that is equals to Vc minus Vj, and that is given minus 1500 kilometer per hour, right? Okay. Is it clear? Clear? Okay. Then what's going on? So finally, the negative sign indicates that combustion products are moving in opposite direction. Yes, exactly. When any aircraft or jet is moving in forward direction, in the backward direction, in opposite direction, what will be happening? There will be the combustion that is going to eject there. Speed of combustion products with respect to observer. So now they have asked us to calculate the velocity with which the speed of combustion is moving with respect to observer. So again, a combined question, right? First, we should know the velocity of jet, observer, combustion. Using these three velocities, we should find that final velocity. Okay, speed of the combustion product with respect to observer will be equal to speed of the combustion minus speed of the observer, right? So please let me explain this more clearly so that you will not have any confusion. Just a second. Yeah, let me just keep it here. I'll be just not looking at your chats for some time. Just I'm explaining here. It's difficult for me to concentrate in both sides. Okay. So see, now we want, if I with 1 second, velocity of airplane. Okay. Products combustion speed relative to jet. Okay. So velocity of jet with respect to observer, velocity of jet with respect to observer is velocity of jet minus velocity of observer, that is 500 kilometer per hour. Okay. Next is velocity of combustion. Velocity of combustion with respect to jet. So that is velocity of combustion with respect to jet, Vc minus Vj. That is given minus 1500 kilometer per hour. Now what they are asking? They are asking velocity of combustion with respect to observer. Okay. So velocity of combustion with respect to observer will be equal to velocity of combustion minus velocity of observer. Is this clear? Till here, I hope it is clear. Right? Is it clear? Yeah. So next, now I don't know what is the velocity of the observer, right? So instead of, well, I don't know velocity of the combustion also. So in the place of velocity of combustion, I am going to use the velocity of combustion with respect to jet minus, I don't know velocity of observer also. So velocity of jet minus velocity of observer. This gives you the final velocity of combustion with respect to the observer. So what it is, the first thing, this Vc minus Vj, that is equals to minus 1500. So negative sign as it is. Vj minus Vbo, it's 500. So I'm just keeping negative sign as it is, minus 500. So what is the final answer? It is minus 2000, what I'm finding here. Okay, so it's plus. One second, one second, one second. So it's plus, not minus. Okay, right. One second. So minus of Vj minus Vo. Vj minus Vo. That is plus. Okay, sorry. It's plus here. That was my mistake. Right? So if I subtract this, I will get minus 1000 km per hour as the ultimate answer. And this is the right answer. Clear now? Is this clear? Right? Uh, is what I'm writing here, is that visible? Or else what I'm saying, just observe them. Okay? Yeah, great. I hope if it is visible, it's good. Or else I'll just share the PPTs. You can find the answer here also. Just a second. I'll just highlight these things so that you can find the answer. So this is the important step that I have written. Okay, just go through the step. Clear with this? Yes, I hope that's clear. So this was about the fifth question, right? So just observe this step. This step is extremely important. How to take it, right? This thing is important. So velocity of combustion with respect to observer will be the velocity of combustion minus jet, jet minus observer. Finally, you'll get the right answer. Because see here, just observe here. Let me write it here. Velocity of combustion with respect to observer is equals to velocity of combustion. Is that visible or not what I'm writing here behind? If it's not visible, let me know that so I can write it in a little away so you can see that. You can see, right? Velocity of combustion with respect to observer will be equal to velocity of combustion minus velocity of observer. In the place of velocity of combustion, we are using velocity of combustion minus velocity of jet, right? Why I'm writing this? Yeah. Plus, we have to use velocity of jet minus velocity of observer. Fine. So now, if I remove these brackets, what you can see here, VC minus VJ plus Vj minus Vo. I can cancel this plus Vj, that is the velocity of jet, which is plus and minus. I can cancel them, and what I'm getting, the final thing, it's again the velocity of combustion minus velocity of, yes, velocity of the jet. Clear with this? Right? I hope that's clear. If you have any questions, any doubts, you can ask that. All right. So we are done with these 5 questions. Moving forward with the sixth question, what it is. A car is moving along a straight line, a straight highway with the speed of 126 kilometer per hour, is brought to stop within a distance. So finally it is stopping within the distance of 200 meters. Okay. What is the retardation of the car? Assumed uniform, and how long does it takes to stop the car? So first let me write the given things, what they have given in the question, right? So let me write the given points. Yes, the given thing is initially it's moving with the speed 126 kilometer per hour. Finally it is stopping, that's 0 kilometer per hour. Distance traveled by it, let me call it as D, is equals to 200 meters. They are asking us what is the retardation and what's the time taken. Fine. So instead of D, let me use yes, as we have been studying about that. Okay. So if I consider the second equation of motion, which is V is equals to U plus, so the first one was V is equals to U plus AT. So we can't use this. The second one was S is equals to UT plus half AT square. Again, no, we can't use. And the third one was b square is equals to u square plus 2a. Yes. Yeah, by using this, I can find the value of a. So let me use this. So it's 0 is equals to 126 whole square plus 2 into a, I don't know, and s is 200. So what I can write this as 2 into 2, 400 a is equals to minus 126 whole square. So a is equals to minus 126 whole square divided by 400. So what is the answer we are getting here? If I solve this equation, right? So what's the answer we are getting? You can find it. It turns out to be minus 3.06. Again, by using V is equals to U plus AT, the first equation of motion, just substituting the given terms. So U is, okay. We have to convert it into meter per second just by multiplying it with 5 by 18. Okay, we will multiply it with 5 by 18 and it converts into meter per second, right? So just substituting them in the equations of motion. First, we'll be using third equation of motion. V square is equals to U square plus 2as. By this, we'll find out the value of A. And then we'll be using V is equals to U plus AT, by which we will find the value of T. Clear? Okay. Let's take a quick break. After that, I'll be continuing with the session. So we are done with the 6 questions. There are still more questions and we'll be discussing about that. Before that, let's take a quick break and I'll be back. Yes, okay, let's continue the session. And yeah, Subramanyam, right? So, yeah, when I'll be teaching here, you guys will be not there. If I take a small break and you'll be asking, ma'am, where are you? Right? Okay, I'm back after a small break of just 5 minutes. Yeah, yeah, after a hour, we can take a 5 minute break, right? Oh, I left my spectacles. Just a second. Yes, let's continue with the next question. Right, right. Can you see me? Let me just check it. Let me just confirm. Yes, you can hear me and see me. That's good. Yeah, let's continue. Okay. So, is this question clear? The sixth question, easy question, basic question, a ninth standard level question, I can say it. The only thing you should remember here is the conversion from kilometer per hour to meter per second. Okay, that was about this. Hope that's clear. Let's move to the seventh question now. And the seventh question is on your screen. So, what's the question? Two trains A and B of length 400 meter and each are moving on two parallel tracks. So both are moving with the, okay, they both are covering a length of 400 meters but moving with different same direction. Okay, let me first read the question fully. Two trains A and B of length 400 meter each are moving on two parallel tracks with the uniform speed of 71 km per hour in the same direction with A ahead of B. Okay, A is ahead of B. The driver of B decides to overtake A and accelerates by 1 meter per second. If after 50 seconds the guard of B just brushes past the driver of A. Okay, he brushes out. He overtakes the path of driver A. What is the original distance between them? Okay, understood. What is the question? Both are covering the same distance. The distance is 400 meters. Both are moving with the same speed. So I can call it V is equals to 71 kilometer per hour. But there's a catch here. And with that catch, what does the B do? B accelerates. So acceleration of B is accelerates with 1 meter per second. Fine. So after the time 50 seconds, the B overtakes A. What is the original distance between them? So what's going on here with the question? There are two trains which are moving on a parallel path. Okay, let me call this one as train A. Let me to try it properly. Okay, I'll just draw it and I'll show you this. Train A is ahead of B. Okay, let us consider this is train A, which is moving on the path, the parallel path, and let's consider here there is a train B. Here there is train B. Okay, and both are moving on a parallel path. of same distance. So this is also moving on a track. This is also moving on a track. Uh, it's not that proper, but just to understand. Okay, just to understand what is going on, what is the scenario here, right? Train A is ahead of B. That concept I want to display here. And they are covering a distance of 400 meter. Both are same, speed is same. Now the distance between them is given once again. So the original distance between them is what? What is this distance x? They are asking us. Understood the question? Is the question clear? Fine. But to the B, the driver of B decides to overtake A, so he accelerates with 1 meter per second. So after 50 seconds, he will be able to overtake him. So what is the actual distance? So that after 50 seconds, he can overtake. Right? So this is the question. Clear? So yes, is there any noise, disturbance? Clear, right? Okay. So let's now see the answer. How we, so shall I erase this slide? I hope that's clear. I'm going to erase what I've written here. You have understood, right? What is going on here? A is ahead, B is behind that, and there's some distance between them. So we have to find that distance, what it is. Okay, then. Let me just erase the slide. And right now, see here. Here the length of the train A and B are equal to 400 meters. The length of the train is 400 meter, not the distance covered by the train. Fine. As both are moving with the speed. That is, so again it's in kilometer per hour and we are converting it into 20 meter per seconds, right? So I hope there's no noise. Okay. So they have given in kilometer per hour. Again, we are converting it to meter per second and that is turning out to be 20 meter per second. And how we can do it? Simply just by multiplying it with 5 by 18. If you multiply the given kilometer per hour by 5 by 18, you will get the meter per second conversion. So, okay. So if we consider the relative velocity, absolutely it will be 0 because both are moving with same velocity. So observe, if you and your friend, or else if you are moving on a vehicle and beside that your friend is also moving on the same vehicle with the same speed, okay, so you can see him throughout your friend, right? So you'll be like feeling it, he's also not moving, I'm also not moving. You'll just think that the trees, the roadside things, just they are moving. Understanding the relativity concept. So when we are moving, we assume that our perspective is the origin, and in our perspective whatever aligns, we consider that is also in a rest. So like this, in this format, the relative velocity is 0. I hope that's clear. Okay. Let initial distance between the two trains, I don't know it, I'm just calling it as yes. So yes is the distance between the two trains. Then B train has to cover the distance yes plus 800 meter. Okay, yes plus 800 meter in order to cross the train A. So let us read this properly. Then B train covers the distance yes plus 11. So let's leave that. Yes plus 800 meters of distance. In what time? In the 50 seconds. So here they are using the equation yes is equals to ut plus half at square. Are you understanding? If there is any doubt, please ask it in the chat. Right? S is equals to ut plus half at square. Which law? Second equation of motion, which you have studied in the 9th standard. Second equation of motion. So instead of A, we are using relative velocity. Instead of yes, we are considering B is traveling yes plus 800 meters of distance, right? And acceleration time is given, just substituting the things. Okay, just substituting the things at that point, calculating, just you can calculate it. 5 5s are 25, double zero, right? If you divide it with 2, you'll get 1250. And what we are doing, we have here 800, right? So next you are transferring this 800, just a second, you're transferring this 800, it becomes minus 800. With this result, if you remove 800 value, yeah, you want to use v square is equals to u square plus 2as, but time also should be included. Okay, um you can try with that, what it turns out to be. If I want to just try it, let's see how much it turns out. Will that be same? Okay, the other catch here is again we should calculate the final velocity. As the train is not stopping, right? So the difficulty with this equation, v square is equals to u square plus 2as. In the place of yes, you can use yes plus 800. In the place of you can use relative velocity. But what is v, right? Again, you should get acceleration, initial velocity, time, and then find the final velocity. So it's more complicated, and this equation is good, you can easily solve with this. Is this clear? Yeah. Initial distance between the two trains was how much it was? So 450 and plus 800, because he's traveling first 800 meters and then the remaining distance is turning out to be 450. Nothing but the total distance between them is, understood? Good. 1250, 1250. So you can consider this is the train, this is the train, and 450, and here the distance of the train is 400 meter, here it is 400, so they are that much apart. Clear? Good. So next question again, moving forward with the next question. What is that? Let me read it out. On a two-lane road, car A is traveling with a speed of 36 kilometer per hour. Okay. Two cars B and C approach car A in opposite direction with a speed 54 kilometers per hour each. Okay, so A is moving like this with the 36 kilometer per hour speed, and B and C are reaching it in from the opposite direction with the speed of 54 kilometer per hour. At a certain instant, when the distance AB is equal to AC, both being 1 kilometer, okay, distance between AB and AC are equal to 1 kilometer. AB is equals to AC is equals to 1 kilometer. Okay. So both are 1 kilometer away from A. B decides to overtake A before C does. Okay, let me read it once again. On a two-lane road, car A is traveling with a speed of 36 km per hour. Two cars B and C approach A in the opposite direction. So there's a two-lane road. In one lane, the car A is moving here in one particular direction. In the other lane, B and C are moving in the opposite direction with the same speed. So when the B and C are 1 kilometer away from the car A, the B1, he thinks that I should overtake A before C does. Before C crosses A, I should cross A. What is the minimum acceleration of the car B is required to avoid accident? Okay, what's the minimum acceleration of the car B is required to avoid accident? So when does the accident goes here, right? We should know that first. Okay. So see here, speed of the car. First, what they are doing again from kilometer per hour to meter per second, just by multiplying it with 8 by 16. So you got the velocity of car A, velocity of car B. Now they are calculating the relative speed. So what is the relative speed of A with respect to B? 25 kilometer per second. Relative speed of B with respect to A is 5 kilometer per second. Okay. Yeah. Yeah. Just see here. Don't consider, if you see like this, you may confuse. The relative velocity between A and C is 25 kilometer. Between A and B is 5 kilometer. How is that possible? Because A and C are moving with the same velocity, right? Then that should be equal. The relative velocity between A and B must be equal to the relative velocity between A and C. Is that true? Yes, it is true. But what it is not A with respect to B. It is B with respect to A. So there's a difference between velocity of B with respect to A and velocity of A with respect to B. Clear with this? So when we are considering this velocity, it is turning out to be 5 meter per second, and here it is 25 meter per second. Okay. Time taken by car C to cover the distance AC. So here there is A, here there is C. To cover this distance, how much time it is taking? So what's the time it's given? It's given 1000 by VAC. Okay, 1 kilometer. Nothing but 1000 meters. Fine. So they are converting 1 kilometer to 1000 meters. So time is equals to distance by velocity. So I'm splitting out the terms what they have given here directly. Right? They have just written time is equal to 1000 by VC, velocity of AC, right? But how is that? So it is distance by velocity. Distance is 1 kilometer. If you convert it, it turns out to be 1000 meter. By velocity, we are finding the distance between A and C. So velocity also we will be considering velocity of A with respect to C. Clear with this? So then you can calculate what is the time. So as we see, we have already calculated it to be 25. So finally, if you divide 1000 with 25, you'll get the answer 40. So C car takes 40 seconds to reach A. Is that okay? So we want to find the acceleration. Moving to the second equation of motion, that is S is equals to ut plus at square. Right? We already know this. S is equals to ut plus half at square. So what it is going on here? Yes, again it's the distance 1000 meters. V yes the sorry u is 50. Sorry, it's 5, right? It's 5. Okay, sorry. It's 5 into 40 is the time what we have calculated, plus half A we have to calculate. T is 40 square. Just solving out this equation, the acceleration is turning out to be 1 meter per second square. Clear with this? Is this clear? Everybody clear? Any doubts? Any questions? It's clear, right? Good then. Let's move forward to the next question. Okay, let's go. Two towns A and B are connected by a regular bus service with a bus leaving in either direction every 10 minutes. That means at every some time in a time, the two buses will be leaving, one from A and one from B. Yeah, connected by a regular bus service with bus leaving in either direction every 10 minutes. Okay, so first this, after 10 minutes this one, after 10 minutes this. It's like that. A man is cycling with a speed of 20 km per hour in the direction A to B. So the person is moving from the town A to B with the cycle with the speed of 20 km per hour. Notices that a bus goes past by him, okay, in every 18 minutes. So he is moving with 20 km per hour. He is moving from A to B and he is observing that there is a bus which is passing by him in every 18 minutes in the direction of motion. Okay. In which direction he is moving? In that direction the bus is moving. Okay. And every 6 minutes in opposite direction. So in every 6 minutes he is finding a bus which is moving in his opposite direction. What is the time period T between the bus and with what speed do the buses pay on the route? Interesting question again. Let's understand first. So, what's the distance between A and B? It's not given, but the speed of man is given. So, let me write V, speed of man. It's 20 km per hour. 20 km per hour from direction A to B. So, he is moving from the direction A to B. So the bus which is so okay. Let's understand. I can directly show you the answer and let's I can explain them. But let's understand the scenario. What's going on here? The person is moving with the speed. So with the time he is going near to B. So the bus which is coming from B is near to him. Understanding what I'm telling? With the time passage, he is moving near to B. Whatever the bus that moves in his opposite direction approaches him fastly in less time, right? So we can see the 6 minutes in the opposite direction because he is actually near to B. He's moving near to B with the time. What happens? The bus that are leaving from B reaches him quickly than the bus which is moving from the point A. Uh, so what is this 6 minute and 18 minute? It is the relative velocity because the person is itself he is himself moving, right? So what I can consider the relative velocity of the bus A with respect to the man is 18 minutes. Sorry, he is reaching in 18 minutes. So relative velocity should be converted into distance per time, right? Okay. So let's consider here. See. Let VB be the speed of each bus. So, okay. Let VC be the speed of cyclist. Okay. Relative velocity of the buses playing in the direction of the motion is VB minus VC, which is the velocity of bus minus velocity of the person, that is the cyclist. The buses playing in the direction of motion of the cyclist goes past after him in every 18 minutes. So 18 minutes, that means 18 by 20 hours it's given. Okay. So again, 1 minute 60 seconds, right? So hours, we have to convert into hours, sorry. 60 minutes, 60 minutes is equals to 1 hour. It's given 18 minutes. So 18 minutes will be equal to, yeah, how much? Okay, let me understand this. So if I want to find the velocity, right? So for 18 minutes, it will be 1 by 60 into 18. right? So at that time, you'll get the answer 18 by 20 hours. So that 18 minutes we have converted into 18 by 20 hours. Distance covered is VB minus VC into 18 by 60. Distance covered, yes. Distance is equals to time traveled, right? So speed into time, V into T. Distance is equals to, yeah, velocity is equals to distance by time, distance is equals to velocity into time. So when we are multiplying this, it's a bit complicated question. Let me be frank here. It's a complicated question. Okay. Bus leaves after every t minutes. Therefore, the distance is equals to t by 60 minutes they have given. So if I convert it into hour, it will be t by 60. Again, here it's not 20, it should be 60, right? Okay. So velocity of the cyclist with respect to the bus is equals to velocity of the bus. What they are calculating here, right? So keeping this analogy, just cancel. You can see from this step to this step, they are just multiplying the equations, cancelling it, taking it in a format, dividing equation 1 and 2, and what we are getting finally, velocity of bus is twice the velocity of cyclist. So the velocity of cyclist is 20 kilometer per hour, then the velocity of bus is 40 kilometer per hour because it is double. Clear? First we found out the what is the velocity of bus. Now we want to calculate time also, right? So the time, capital T, what is that? The what in that alternate time, the buses will be leaving from either of the stations, right? So from one station one time, after this 9 minutes, another bus will be moving from the part B of the place. So how to calculate this? Again, you can see 40 minus 20, nothing but the relative velocity of B with respect to C. The same one, the same in any one of the equation, you're going to substitute and you'll find the value of T. Is that clear? Little bit it's complicated, but finally what they are doing, in any one of the equation, they are substituting all the terms and they are finding T value. The important thing what you have to find out here is the velocity of bus is twice the velocity of cyclist. So this is the important thing here. Clear? Is this clear? Any questions? Clear, right? Okay. Just be going through this question. Okay. I'll be just back quickly, right? So let's take a quick session and let's be back. Till then, just keep going on through the question, right? I'll be back. Yeah, let's continue this session. Shall we continue, right? We can continue the session. You can hear me and see me properly. So, what is the 10th question? A player throws. Okay, let me read out. I'm going to start with the session. Okay. So, if you have any questions, any queries, you can just ask that. Clear? Right then. Let's start the session. A player throws a ball upwards with the initial speed of 29.4 meter per second. Need not to convert it again as they have given in the meter per second. He's throwing it with this initial speed, that is u is equals to 29.4 meter per second. What is the direction of acceleration during upward motion of the ball? So what is the direction of acceleration? So anything is moving in any direction, maybe right, left, up, down, but it will be experiencing a gravitational force in downward direction. We know that, right? During upward motion of the ball, it is moving upward because it has some velocity in the upward direction, right? So we will see that. What are the velocity and acceleration to of the ball at the highest point of the motion? I have said this many times. We have been discussing about this from in your ninth standard also. Whenever if you throw anything, when it reaches its maximum point, after that it will fall downward due to acceleration of gravity, and its velocity is zero here. It does not have any velocity, so it will fall in the it will not move upward. Instead, it will stop and fall in the downward direction. Okay, choose the x is equals to 0 meter and time t is equal to 0 seconds to be the location and time of the ball at highest point. Okay, in the highest point we should consider it as a 0 second 0 meter. Vertically downward direction to be the positive direction of x axis. Okay, so we should not consider our standard units like upward direction is positive and downward direction is negative. Here they are telling consider downward to be the negative. Okay. Sorry, consider downward direction to be the positive one, and give the sign of position, velocity, acceleration of the ball during its upward and downward motion. In an inverse way, they are giving us, and we have to tell what is positive in the upward motion and what is negative in the downward motion, and so on. Okay. To what height does the ball rise, and after how long does the ball return to the player's hand? Clear. So these are the questions. So now we have to find the answer for this question. So they have just given us the initial velocity and rest of the things, some analogy. We have to find all the thing. Clear with this? Understood? Let's solve it. Let's solve this. Okay, great. So see here. The direction of acceleration during upward motion of the ball is vertically downward. As I said, it is the acceleration due to gravity which is acting in downward direction. Instead, the ball is moving in upward direction, but acceleration due to gravity always acts towards the earth, hence it is downward direction. Is that clear? Right? At the highest point, velocity of the ball is zero, but acceleration in the vertically downward direction. So as I said again, in the highest point, acceleration, the velocity will be zero, but again the acceleration is in downward direction. If we consider highest point of the ball of the motion at x is equal to 0, t is equal to 0, and vertically downward to be positive, vertically downward, actually we consider it negative, but here they are giving consider it positive. Okay, if we agree to this, during upward motion, the ball before reaching the highest position, its displacement x is considered to be positive, but the velocity is considered to be negative and acceleration is positive. So acceleration we are considering it to be positive because they are telling whatever that is going in downward direction, consider it to be positive. So during the downward motion of the ball after reaching the highest point, x, v and a, which is a is equals to g, all three quantities are considered to be positive as it is moving in the downward direction. So when the ball is falling in the downward direction, all the quantities are positive, including the distance, velocity and the acceleration. Okay. During upward motion, so the final question was, to what height does the ball raise and how long it takes to return? So initial velocity, we know it is given, and considering it to be negative, it is 29.4 meter per second. Acceleration, we already know that acceleration due to gravity 9.8 meter per second square. Finally, it is reaching to ground or the highest point. So velocity will be 0 at the highest point. Okay. So using the equation v square minus u square is equals to 2as. We are just substituting the terms, and a value we already know, u value know, v value we know. So we can easily calculate s. That is the only unknown term in the equation. So just rearranging the equations given, we can find the displacement over here. Yeah. Yes. Okay. So distance we can know from here. Okay. So, and then we have to calculate the time also. Yeah. So we have to calculate the time also. So we are going with the first equation of motion, which is v is equals to u plus et. Just substituting the terms that they have given, again the acceleration, velocity and all, we can find the time. So the time is 6 seconds. Why 6 seconds, ma'am? It's 3 here. It is the time of ascent. So they are asking when it returns to the one who has thrown that ball, right? The player, when it returns to his hand, right? It is the question. When the ball returns to his hand. Yeah, first equation of motion, right? So the time of ascent is 3 seconds. It will be equal to the time of descent, which is also 3 seconds. So the total time required for the ball to return to his hand is 6 seconds. 3 plus 3, it is 6 seconds. Clear? Clear with this? Clear with that? Yes, we are using here the third equation of motion, right? First, we are using third equation of motion, and here it is first equation of motion. Right with this? Shall we move forward now with the next question? Right. Let's move forward with the next question now. The 11th one. Read each statement below carefully and state with the reasons and examples if it is true or false a particle in one dimension motion. So the question is based on 1D motion, the particle moving in one dimension, one straight line. So that's called as one dimensional motion, and they are asking which of them is true or which of them are false. Give the reasons, examples to prove that yes, it is true or yes, it is false. With zero speed at an instant may have non-zero acceleration at that instant. So in some instant there is zero speed. So does it means the acceleration may be non-zero? Yes, acceleration may be non-zero. We'll be discussing about that. With zero speed may have non-zero velocity. If the speed is zero, can the velocity be non-zero? It's a question. With constant speed, must have zero acceleration. With a positive value of acceleration, must be speeding up. Yes, positive value of acceleration means that it is speeding up, right? As I said, it's true. With a zero speed, it can have zero acceleration because velocity is not zero. The what I can say, the direction is changing, right? So, for example, it's given here at the highest point, right? Right back in the question, we have seen the velocity here will be zero, the highest point, but there will be acceleration. So, it is not mandatory that if velocity is zero, acceleration should also be zero. So, that is it stating here. The first thing, right? Zero speed, you must see the acceleration is not zero. Yes, it's true. What about next? Next one is false because velocity is nothing but the magnitude of speed and acceleration. Okay, so let me be clear here. Velocity is nothing but speed with a magnitude. Okay, speed with a direction. Speed plus direction gives me velocity. If speed itself is a zero, speed is a magnitude. Direction does not give any value, right? Speed is the magnitude. If speed itself is zero, then how can there be velocity? Velocity will also be zero. Understanding what I'm telling here? Okay. So if there is speed zero, then of course velocity will be zero, but not the acceleration. Next one. Next is with constant speed must have zero acceleration. Yes, if the speed is constant, that means velocity is also constant. And velocity constant means zero acceleration. So the C thing is true, right? See, a speed is constant, nothing but velocity is constant. Velocity gives us zero. Yes, yes, no worries, fine. You can see it now, right? Didn't got this? Okay, you came late, so you're not understanding. No worries, let me explain you quickly with these things. So the question, yeah, I can repeat. No worries, I'll repeat it. No worries, I'm explaining. Okay, so listen carefully. So, in this question number 11, they are asking us to tell what is true, what is false, and give some reason example regarding this. So, the first thing is telling zero speed at some instant. So, speed is zero. So, that can have non zero acceleration. That means that in some object, in some condition, speed will be zero. Can it have non zero acceleration? Can it have? Yeah, tell me the answer. Speed of the object is zero, but acceleration is not zero, what they are telling here. Yeah, so the first equation is telling v. Okay, let me not use vector. If I use vector, it will turn out to be velocity. Here we are speaking about speed. Speed is zero. Can acceleration be not zero? So is it true? What do you think? What do you think the answer is? Quickly in the chat. What do you think the answer is? Yes, anyone quickly in the chat? I have just explained that, right? What's the answer? Is it possible? Yeah? Okay? Okay. So let me explain. See here, so the yes, it is true. The first thing is yes, it is true, because in just this example we have seen in this problem, right? So whenever if a person is throwing something vertically upward, it will reach a maximum height. After that, it will fall in downward direction. When it is reaching the maximum height, its speed will be equal to zero. Its velocity will be equal to zero in the maximum height. Okay, in the maximum height condition, velocity of that object will be zero, but acceleration will be acting in downward direction. So there is zero acceleration but non-zero velocity, and yes, this is true. Okay, and the second thing is, so Sanjana, are you listening to me? Right, you are asking me to repeat this thing, so I'm repeating it for you. Okay, so zero speed may have non-zero velocity. No, it's not possible. It's false. Why? Because velocity is nothing but it is the speed with direction. Speed is the magnitude of velocity. If magnitude itself is zero, then velocity is also zero. Understanding what I'm telling? Let me give you an example. So let me consider here a vehicle moving with 500 kilometer per second. So what is this? This is speed. So now I will say a vehicle is moving in north direction with 500 meter per second. What is this? This is velocity. Again, this is for the 500 thing. Now if I say the speed of the vehicle is zero, it's not moving itself, then how it can move in any direction, right? It will be zero. Velocity also zero. If speed is zero, velocity is also zero. Clear? Right? And the next thing was constant speed must have zero acceleration. Yes, because speed is constant, nothing but velocity is constant. Rate of change of velocity gives acceleration. Here, the velocity is itself not changing, then acceleration should be zero. True. Agree with this? Yeah. What about the next thing? With positive value of acceleration must be speeding up. So false, true only. Okay, it's given here. Positive value of acceleration must be speeding up. True only when the chosen position direction is along the direction of motion. Okay. Yes, yes. Hi. Hi, Pranav. Okay. So if I tell that here there is a vehicle, okay, and it's moving in this direction and its acceleration is this direction, which is positive, then I can say that it is speeding up. Okay, and let's consider there is, let me draw it here. There is another vehicle which is moving in this direction, and we are telling this direction acceleration to be positive. It's not speeding up. I'm considering it as a positive acceleration, but it is opposite to the direction of motion. Nothing but it is slowing down the vehicle. Is that clear? Is that clear? Tell me quickly. I think most of the students are watching the IPL cricket match. I think they are busy in that, right? Shall we move forward? Proceed with the thing? Shall we move now? Yes. Then let's move to the next question. The question number 12, and that is on your screen. A ball is dropped from a height of 90 meters on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Plot the speed time graph of its motion between time t is equal to 0 and 12 seconds is the question. Fine. So let's understand the question what they have given. A ball is dropped from the height. So the height of the building is given 90 meter on a floor at each collision. So it is bouncing. It is not just dropping and stopping there. It is bouncing. So it's given at each collision with the floor. The ball loses 1/10 of the speed. So the speed is reducing. We know this generally also, right? When you take a ball, you hit it on the ground, it will bounce. Just leave it as it is. After, you can observe the height of bouncing. It will be bouncing with more height, then less. With the time, the height reduces because speed of the ball is reducing, and finally it comes to the rest. Right? We have already seen this. It's not big physics that you don't know. You know this already, right? uh, Plot the speed time graph of its motion between the time t is equals to 0 to 12 seconds. So within this time frame 0 to 12 second, what is the speed changing, how it is changing, we have to draw the graph for that. Okay. So as the it is just dropped from the height, so initial velocity is 0 and acceleration is nothing but acceleration due to gravity. It is considered here to be 10 meter per second square. Distance is given 90 meters and the time interval is 0 to 12 seconds. Velocity, what's going on with the velocity? So velocity is changing with time. As the time goes, velocity reduces. So velocity is changing with time and we have to find this. So first what they are doing, they are calculating this velocity without using the time, right? V square is equal to u square plus 2as, third equation of motion. V, we don't know, u is 0, 2a is 10, s is 90. For, from that we got the velocity to be 30 root 3. So what was the initial velocity? It is 30 root 3 meter per second. Now, again using this velocity, we are finding the time. At what time it is 30 root 3, right? Using the second equation, s is equals to ut plus half at square, and substituting the terms in that, we are getting the time t to be 3 root 3. That means that in the time 3 root 2, the velocity of that object is 30 root 2. So that we can plot. So the initial velocity of the ball was 0. When we throw it, it reaches its maximum velocity, which is 30 root 2 in the time 3 root. Clear till here? Right? Is it clear? Then what's going on? Rebound velocity. It's going to hit with this velocity and it's going to rebound. So what is that velocity? It's given 9 by 10 into 30 root 2 meter per second. Right. So I can cancel this. This is 3 into. Okay, what they are doing here, rebound velocity. Uh, just canceling the zeros and 3 ones are 3 threes are we can do. So the rebound velocity is turning out to be root 2 meter per second. Right. So the rebound velocity is root 2 meter per second. Yes. Time taken to reach the height of the point. So sorry for the disturbance. Okay. So the time taken to rebound velocity, it's turning out to be root 2 meter per second. Okay. And time taken to reach the maximum height is 27 root 2 by 10 seconds. Clear with this? Okay. So concentrate here. That was the answer. Fine. Time taken to reach the maximum height is 27 root 2 by 10, which is turning out to be 2.7 into root 2 seconds. So the total time is 5.7 into root 2 seconds. So actually they are not asking about these calculations. This will help you to plot the graph. They are asking just to plot the graph, right? So it's going to change. You should just, it's just to mark these points. Clear with this? Going forward with the next question. Uh, So we are with the 13th question right now. Explain clearly with example the distinction between. Okay, let's read out what it is. Magnitude of displacement over an interval of time and the total length of the path covered by the particle over the same interval of time. So what's the question? Magnitude of displacement over an time interval of time and total length of the path covered by the particle over the same interval of time. Displacement and distance are the not same thing, right? So they are talking about the distance and displacement. So it's not true, right? Distinguish? Yes, there is a difference because here it is being given regarding displacement. Total path covered is nothing but distance, and we already know what is the difference between distance and displacement. If a particle is moving from this point A to somewhere like this to the point B, which he is traveling with, let me call it as 50 meters, and someone is directly reaching from here to here. That is what displacement is. Let me call it as 10 meter. So you can find distance to be always greater than displacement, right? So it's given the second quantity is more than the first one, right? Second quantity is greater than the first one. Clear? Is this clear? First one. Okay. What is the next thing they are asking here? Magnitude of average velocity over the time interval. So we are taking velocity's average and its magnitude. Okay, not direction. And the average speed over the time interval and the average speed. So is these things same? So suppose if we are considering an example that in a time t, a particle is completing its journey, then magnitude of average velocity over the time interval will be equal to magnitude of displacement by time interval. Nothing but what is finally going on here, the second quantity average speed is always greater than the magnitude of average velocity, because here we are considering displacement, here we are considering distance, right? And again we know that distance is greater than displacement. Distance by time is speed, displacement by time is velocity. So as distance is greater than displacement, speed is also greater than velocity. Clear? So, and they can be equal, they will be equal if the particle moves straight away from one point to other point. In this kind of conditions, okay, if something is moving from here to here in a just a straight line, yes, I can say that distance and displacement both are equal. Understanding what I'm saying here? Is this clear? Tell me quickly, is this clear? Right? Okay. Let's move to the next question now. Hoping that that's clear. The 14th question. A man walks on a straight road from his home to a market 2.5 meters away with a speed of 5 kilometers per hour. This is like the question that we have solved regarding the woman who is going to his her office, right? So 2.5 kilometers away. That was also same. So what the man is doing, he's going on a straight road from his home to the market, which is 2.5 kilometers away. So with what speed he is walking? With 5 kilometers per hour speed, he is going to the market. Finding the market closed, he instantly turns and walks back with a speed of 7.5 kilometer per hour. You can see that when he was going to the market, he was not interested. So he was walking with the less speed. He was going around, say, with the speed of 5 kilometer per hour. But when he saw that the market is closed, he was hurried to reach his home. He turned back quickly and he started to walk with a velocity or with the speed of 7.5 kilometer per hour. Speedily, he started to rush towards his home. Okay, this is the condition. So the good thing in the physics is you'll get to read the stories in the question, right? So I have done a video regarding Leonardo da Vinci. In that, I have explained how the science and arts are combined things. So what is going on here? The man is walking, he's returning. So this is like a story, right? In that story, we have some numbers, and by using some numbers and physics, we are going to solve the problems. This is what goes with most of the questions in physics: story, numbers, physics. Nice thing about physics. Okay, fine. Okay, he ran back to his home. What is the magnitude of average velocity? So, what we have to calculate? We have to calculate the average velocity. And it is at, and what they are asking? Average speed of the man over the time interval 0 to 30 minutes, 0 to 50 minutes, 0 to 40 minutes. Okay, why these many? Let's know. Note, you will be appreciate for this exercise why it is better to define average speed as total length divided by time and not as the magnitude of average velocity. You would not like to tell the tired man on his return home that his average speed is 0. Oh my god. Okay, this many things. Fine. Let's solve them. Let's cater it one by one properly. So I can write the given terms, but yeah, if you want, let me just note it here. The given things, the speed of the first, the market is 2 point. Let me just keep it aside and let me write it. The market is 2.5 kilometers away. His initial velocity was 5 kilometer per hour, and after seeing the market closed, his velocity is 7.5 kilometer per hour. Fine. So these are the given terms. And A, what they are asking? Average velocity. So what is average velocity? Sum of velocities by time, total time, right? And the other thing that is they are asking is average speed. Average speed is total distance covered by time. Okay, so this is to differentiate and with different time intervals. So different time intervals they are asking. Total distance by total time. Total time here is 30 minutes. Here in the second condition it's 50 minutes. So again, if I should convert this into what in hour I can convert and second, right? But minutes will not be using it directly. Okay, so let me show you how to do this. Right. So V is nothing but velocity is equals to distance by time. So time is equals to distance by velocity. So first what we are doing, we are trying to calculate the time. Okay. So time taken is equal to T is equals to S by V, which is turning out to be 0.5 hours. Okay. So we are converting it into hours because distance is kilometer, right? 2.5 kilometer and velocity is given in terms of kilometer per hour. That is 5 kilometer per hour. So for the, if I consider the initial velocity, and distance. So I'm calculating how much time he takes to reach the market. First, he should go to the market, right? So what is the time he is taking? Let me draw it here simply so that it will be easy. So he is standing here 2.5 meters away. The market is kilometers away. Here there is a shop where he wants to go, right? Okay. So he is moving with the speed of 5 kilometer per hour. So what is the time taken by him? We have seen it as 0.5 hours. So how much time he is taking to cover this 2.5 in first half? First half he is taking 0.5 hours. Why I'm calling it first half? Because when he sees that it is closed, again he is going to walk back to his home with the velocity of 7.5 kilometer per hour. But at this time he is moving speedily, so I can say that he takes less time to reach his home. Clear? So what is that less time? Let's see. So it is 2.5 by 7.5, which is turning out to be 0.33 hours. So first, to reach from the home to the market, he took 0.5 hours. Then to return back, he took 0.33 hours. Fine. So now, average velocities we are finding out here. And yeah, we can find first the average speed, right? So average speed between 0 to 40 minutes. That is the one thing they are asking. Average speed, average velocity. Okay, fine. Average speed is nothing but total distance by total time, right? So what was the total distance? Uh, yeah. Let me come to here later so that this is only this manner is only fine to go with. So average velocity 0 to 30 minutes. Change in distance by change in time. The change in the distance is 2.5 kilometers and the change in the time is 0.5 kilometers. So what is the average velocity? 5 kilometer per hour. Okay. Then average velocity between 0 to 50 minutes. Let me break this down properly. So 0.5 is nothing but 1 by 2, right? What is 0.5? 1 by 2? What is 1 by 2 hours? Yes, it is 0.5. Why is what is 1.5 0.5 hours? 1 by 2 hour, nothing but half an hour, 30 minutes, half an hour, 30 minutes. He will be moving with 5 kilometer per hour speed. Clear? Clear? Okay. So this is for half an hour. But here we are speaking about a hour, less than a hour, which is 50 minutes. Fine with this. So at this time, he is moving and he is moving back also. He is going to his home and he is returning from his home also. Okay. So what's the total time? By total path. That is turning out to be while the total journey from home to the shop and shop to the home, it is 88 kilometer per hour. And between 0 to 4, it's for very small time. They're asking us for 4 minutes, small time, right? So 4 minute, we are converting it to hours. And then the distance, we are reducing it. Understanding what is going on here. For 30 minutes, it's 2.5. For 4 minutes, you have to convert it and you'll get the value. Right? Clear? Clear with this? So we are done with the 14 questions. The last one, 15th question is remaining. The 15th question is remaining now. Shall we proceed then? Clear? Let's do a thing. Let me take a quick break, okay? And let us discuss some more questions, okay? Let's discuss some more questions. So let me take a break, go through the answers. I'll be back quickly, right? Or else we can do a part two of the session also with some more questions. Yeah, let's do a thing. Let me just show you the recap of the session. I mean, let's revise the things. Okay? Okay. So let's continue. I hope that's clear till here, whatever the questions we have discussed. Let me just wait. So, can you see me? So, yes, as I said, we are done with the 14 questions and one more question is remaining. Let's discuss that. Okay. So, we are going to discuss the top 15 questions. If you want me to discuss these kind of questions from your NCRT, good level of questions from all other chapters also that I'm going to cover, as I have already done the motion chapter, force and laws of motion, right? From tomorrow, and that's the important update also. I'll be giving you at the end of the session. So wait till then. And yeah, I was speaking about, so theory sessions are already going on, but if you want the question numericals or the important questions kind of sessions, right? So let me know that in the comment so that I can plan more sessions like this, which are based on the numericals, which are based on the important problems, questions, right? So let me know that if you want in the comment section, right? Not in the chat, in the comment. So that is, we can see that and we can plan for that. Okay. So this question is clear, right? I hope that's clear. And let's move forward. Moving forward with the next one, right? The 15th question. Okay, it's related to exercise 3.13 and 3.14. So back to questions what we have studied, it is related to that. Okay. We have carefully distinguished between average speed and magnitude of average velocity. So, average speed and magnitude of average velocity are not the same thing. We can say somehow, we can say speed is similar with the speed is similar with the magnitude of velocity. Somehow we can say that, but the average speed and the magnitude of average velocity are not equal. So this should be clear with you, right? You should be clear with this. Okay. No such distinguish is necessary when we consider instantaneous speed and magnitude of velocity. So, as I said, if we are considering the speed as an instantaneous speed and we are comparing it with the magnitude of velocity, we don't require to distinguish them. The instantaneous speed is always equal to the magnitude of instantaneous velocity. Why is the question? Understanding the question, what they are telling us, from back to exercise we have been proving, studying, knowing about that. So what we are knowing, let me write it. Average speed is not equal to magnitude of average velocity. This is what we are proving, this is what we are discussing from past two questions. But the question present here is, but they are telling this is not equal. But this instantaneous speed is equal to the magnitude of instantaneous velocity. It is equal, but why is the question. Clear? Clear with the question what they are asking? Right? So why is it? Let's know. Let's know that. Let me erase what I have written. Yeah. See, instantaneous velocity of a particle is about a velocity at particular time. Instantaneous is nothing but suddenly. If a vehicle is moving of 5 kilometer per hour, 10 kilometer per hour, whatever may be the speed velocities. But if I ask exactly at 5 seconds, what is the speed? Exactly at 10 seconds, what is the velocity? So exactly at a particular time. Okay. So what is instantaneous velocity? First we should know that it's the velocity at particular time instant. At particular time instant. So understand that. In this case, so particular is important. In this case of small time interval, time, right? Small time interval that is called as delta t. The magnitude of displacement is effectively equal to the distance traveled. The particle in the same interval of time. Therefore, there is no distinguish between instantaneous speed and the velocity. Let me explain you guys. So here there's a point A and here there's a point B, right? So there's a vehicle which is moving in this path. It's not moving straight away, it's moving in this path. So what is the average speed here? So it's very important. Please observe. It's moving in this direction. Okay. What is average speed? What is average speed? This is, let me call it as total distance. So average speed is equals to total distance by total time. But what is average velocity or magnitude of average velocity? I'm not considering the direction, but it is displacement. And what is displacement? This is the displacement, right? So let me call with capital D. So what is average velocity? It is displacement by total time. Is the two things same? If I consider the magnitude of velocity also, these two things are not same. This is what we studied initially. But when we talk about instantaneous at some particular instant, so it's a very small time. Let me consider the time from here to here, very small time. So in this time, please see it carefully. Okay. In this time, this okay, let me call this was the distance of 5 kilometer, and here the distance is 7 kilometer. So the particle is moving from 5 kilometers to 7 kilometer. Can you see the motion in a small interval of time as a straight line here? Straight line from 5 to 7, 5 kilometers to 7 kilometers, we can find a straight line. So what it is telling us, at particular instant, if we consider instantaneous speed, instantaneous speed, it is also the total distance by time. And what is this? The total distance at a small point is equal to the displacement, right? When this total distance and displacement are equal, then of course, obviously, we can say that velocity and speed are equal, right? Understanding what I'm telling here? Velocity and speed are equal. So, this is what the final question is talking about. Clear? Got it what I'm saying here? Right? Is it fine? So I have drawn it for you guys so you can understand this clearly. Clear, right? Any doubt? Any questions? Anything if you want to discuss regarding this, let me know it in the chat or put it in the comment if you're not watching this live. Just put your queries in the comment section. I'll be going through that and I'll let you know the response, the answer to your question. I hope everything is clear. Let me just display all the questions once, just as a revision, right? So let's recall what we have studied quickly. So, discussing with the first question that was regarding point sized object, right? So, what is point sized object? If it is traveling a very long path, its size is very small compared to the distance covered by it. So we call it as point sized object. This was the meaning that this first question was convincing us about. Right? So it was asking us, is this a point sized object or is the monkey is a point sized object? These kind of question. So what is the understanding of this question? What are point sized objects? If it is covering a large part, where a part of the it's covering a large path but it's very small comparative with that, we can consider that to be a point sized object, right? Moving to the second question, what we were discussing here, this question, as I said, it was a graphical question. This is to test your graph knowledge. So with the understanding of the graph, I can see that A and B are living from same place because in x-axis they are starting with the origin. For time, I can see A is starting with the time 0, origin time, but B is starting its journey delayed with the observation of graph. Then I can see that A is leaving his path late, he is leaving from his school after some time, but he is overtaking A, he is moving very fast than A, so he is crossing A and moving forward. And B, by seeing the graph in the x-axis, we'll find P first, Q first, then. So P is near to O. That means that home of P, A, that is P, is near than Q. But B is reaching, right? So all this analysis from a particular graph, single graph, you must be able to say without any question, without any analogy, just seeing at the graph, you must be able to answer the questions. Understanding what I'm telling you, right? So graphical understandings are important. Then this was a good numerical, right? Yeah, we have solved the numericals. Again, need not to explain. The woman starts the walk, right? So it's we are calculating at what time she is reaching her office and from at what time she is reaching her home. So that calculation has to be done here so that you can mark on that graph. And you can see that from 9:30 to 5, she is staying in her office. She is not moving. So the velocity is zero. When velocity is zero, that in the distance time graph, you'll just put a straight line, right? Which is parallel to the time axis. Should know the understanding of graph again here. Next, what we saw? We saw the walk of a drunken person. So the drunkard person is walking, right? So we should be aware that he is moving 5 meters forward, 3 meters backward. So the net displacement, net what he is moving forward is just 2 kilometers for 8 seconds. You should get this understanding. With this, you can plot the graph. And you'll get to know that after 32 seconds, he will walk 8 kilometers. In 5 seconds, he's going to move forward 5 meters. So the net displacement, 13 meters. After 13 meters, there is a pit. He's going to fall in that. And yeah, what is the time that is required? 32 plus 5, 37 seconds. Right? And then we saw this relative velocity concept, how to use that, right? And this was about simple question based on 9 standard knowledge. You can solve it. Just the catch here is you should know to convert the kilometer per hour into meter per second. So that's the catch here. Fine. Moving forward, the train problem. Again, a good question. We have solved it, right? A little bit complicated one. Yeah, this was easy question, right? Again, relative velocity concept. And all this, if you want, I can provide this PDF, right? You can just go through the things, whatever they are, right? So you can show all these things. Fine, guys. So, yes, these 15 questions we have been discussed, and this was about the session, right? So, yes, this was about today's session, and let's meet again. So, I was telling that there is announcement regarding at the end of the session, right? So, that is tomorrow at 9 a.m. I'm going to discuss the gravitation chapter. Uh, One of my most important favorite, not important, it's one of my most favorite chapters that exist in the 11th standard, right? Gravitation, really beautiful lesson. So I'm going to start it morning 9 a.m. So stay tuned. Okay, be awake and be ready for the session. I'll be taking the class for gravitation. We'll also be discussing it as part 1 and part 2. Gravitation part 1 tomorrow 9 a.m. morning. Okay, so stay tuned for that. And yeah, thank you so much for watching the session. I hope the sessions are helping you. If you need some other things, if you need some more things, let us know that in the comment section. So by seeing your comments, by seeing your need, we can provide you the content whatever you need, right? So the things what you're preparing, whatever you're doing, right? So let us know that in the comment so that we can support you guys. Okay, and also, if you're new to the channel, if you're not subscribed the channel yet, then do subscribe to the channel, because the channel is going to provide you the really good content in a regular basis. Daily teachers will be coming here. They will be teaching you guys every subject like physics, chemistry, maths, bio, right? We are you I think you guys have seen during the time of exams, we have also took up the sessions for social studies, mathematics, and your IACS, right? So we'll be supporting you guys in all the way. So don't think that only this I will get from the channel. Whatever it's required, we are going to provide it, right? So regarding your education, so stay tuned with the channel and also share the channel with your friends so that they can also join and they can also get the benefit of this channel, right? We are doing this we are doing this all for you students itself. So don't forget to like the video if you like it, and share the video so that they can reach to many students, and also subscribe the channel to get more content like this. And really thank you so much for watching the session, and let's meet again in the next session. Bye bye.